And that's Symbolic Toolbox of MATLAB, which has a bunch of different nice commands. This is also very good for your project, the bonus project. So MATLAB can do a bunch of things in a symbolic manner, right? And it means it doesn't solve for anything you're asking it numerically. It is trying to do it analytically. And it can do a bunch of things, okay? For example, let's say I want to work a little bit on my calculus knowledge, or test you a little bit maybe. Who feels confident in their calc? There we go, excellent. Yeah, raise your hand, be confident. So here, we're going to define a function and take a derivative out of it. So in order for defining symbolic variables, you cannot say x equal 10 or something. It's symbolic. So you have to start with saying sims x or y or f or whatever you want. Okay, so the variables that are symbolic, you have to first tell MATLAB, hey, this x is a symbolic variable. You define it. And now you say, for example, f is equal what? Arctangent of x. Now you want to take a derivative from this function, the first derivative. So what do you say? You say diff. The command to differentiate analytically is called diff. Diff f with respect to x. And you can even provide the number of derivatives. How many times? One time. Provide derivative of f with respect to x one time. And there we go. What is it? Plus 1. The derivative of arctangent is 1 over x squared plus 1. Now, if the way it is showing it this way is not easy to read, there is a command in MATLAB that is actually nice. And that is called pretty. Seriously, yes. Pretty of answer. Look. Then it shows it in a way better readable, more readable manner, right? So it's actually drawing the line and everything and making it a lot better looking. So the command diff. Now, if you wanted to differentiate f with respect to x twice, all you needed was to what? Diff f with respect to x 2 times. And now you got this. And again, if you wanted, you could use pretty of answer. And now you got the second derivative, negative 2x over x squared plus 1, the whole thing squared. So this command diff is one of your best friends. Right? There is the opposite of that, which is the int command, integral, both definite and indefinite. So here you define a function like g, and this g is 1 over what? 1 plus x squared. Or let's make it different. 1 over x. Let's make it simple. 1 over x. So this g is a symbolic variable, 1 over x. And now I want to say, what is int of g with respect to x? Yes. Now let's talk about that. If you define a variable and now you create a new variable using an assignment as a function of that symbolic variable, should you ahead of time define that as symbolic? The answer is no. I don't have to. For the f, I did not have to. I just wanted to show you different ways. Because x is symbolic, when g is a function of x, automatically, if you look, g will be assigned symbolic. So in the beginning, if I did not define f as symbolic, still would be symbolic when I say f is arctangent of x. Okay? So independent variables should be declared, for sure. Dependent, you don't have to. So let's see. Here. So here you don't need to provide that necessarily. So here I said int of g, and g was what? 1 over x. And what is the integral of 1 over x? Natural log. And as I said, I told you in the beginning, in MATLAB, whenever it says log, it means natural log. If it's log 10, MATLAB says what? MATLAB says log 10 of x. Okay, so in MATLAB, log without any number means natural log. And you clearly see it got you the right answer. So now let's do another one. G equals what? 1 over 1 minus x squared. The square root of that. What is this one? So it's 1 over square root 1 minus x squared. What is the integral of this guy? Anybody knows? Hyperbolic. Maybe. So this is this integral. Is that arc sine? Yes, it is a sine. Okay, a sine is arc sine in MATLAB. Sine inverse. Okay, so the command int and the command diff are really good. Now, int here, you saw int did what? Indefinite integral, but if you want, you can pass to it what? The upper and the lower limit. So let's say I want to do this integral, but I want to do it, let's say, from what? -1 to 0.5. Okay, so what do? You provide -1 and then what? 0.5, and that makes it definite integral. Here we go. 2 pi over 3. That's the answer. Right? In this case, pi minus pi over 3. Are we good about integral and derivative? So these two are big help for your calculus. So I mentioned them. Good. Now, can we plot symbolic functions? Yes. In order to plot something, they do not necessarily have to be a bunch of numbers. Right? I said x equals what? From 0, a bunch of points, to 100, y equals sine of x, then plot x versus y. So if even I have a function like this g, I still should be able to plot a symbolic function. But to plot it, the command is not called plot, it's called easy plot. You say easy plot of g. And boom, you got your sine inverse. Okay? Let's use another function. What was f? F was arctangent, right? Here, you probably recognize arctangent easier. The sigmoid function, we call it also sometimes. Okay, so easy plot. Symbolic plot. Now, can I provide a range? Like here, I did not decide. It just went for me from almost -2 pi to 2 pi. What if I want to change the range on the x-axis? Can I change that? Yes, you can. So just provide it in brackets. So let's say I want it from -4 to 4. Here. Okay, so just provide your x limits in a bracket, and that would do the job for you. Easy plot. We have a bunch of other things. 1, limits. Really? Yeah. You can do all of the limits in calc here. The simple command is called limits. That's all it is. Let's say, for example, we say h is equal to sine of x over x. Right? This function. What is the limit of h as x goes to what? In this case, x goes to 0. So what's the limit of h with x going to 0? 1, right? You probably all know this limit, correct? Hopefully from your calc. That the limit of sine of x over x as x goes to 0, you take a derivative from both sides. This is going to be cosine of x. This is going to be 1. And you'll get a 1, correct? This is called the L'Hopital's method. So yeah, you can do all of your limits of calc here with the command limit. What else? Solve. Here you have an algebraic equation and you want to find the roots of that algebraic equation, if it's possible. Look what it does. For example, let's say I have an equation like this. X to the 4 minus x cubed plus 2x plus 5 equals 0. Correct? What are the solution to this? So all you need is to provide that inside the command solve if they haven't changed it. I'm not sure if they have changed it or not, because they constantly change their stuff. So let me try it. They constantly change the symbolic operations. Yeah, yes, clearly. Now let me get rid of this part. Oh yeah, they need now double equal sign. We have to change this, okay? Because this used to be working a few years ago when I taught this. Now if you see here, it says now you have to use double equal, and they changed everything. So now when you want to do it, you have to define it using what? Double equal sign, and do not use brackets. So what you need is this basically. Oh, wait, here. And these are the solutions. Now for that equation. Now in this case, I wanted what? X to the 4 minus x. In this case, this is what I want. So I just provide it. And guess what? When you see this, do you know what it means? When it returns the same thing for you, it means, sorry, I could not solve. Okay? It cannot. When you do symbolic or analytic, not every equation I pass to you, you can solve. Okay? Yes. Analytically, yes, there is. It is hard. Why do you think it's easy? Do you have a solution for it? What do you do about 5? If your equation is higher than second order, in general, there is no solution. If you have a cubic, fourth order, fifth order, there is no analytic solution. Okay? If you want to find the roots of this, it has 4 roots. The roots have to be found numerically in general. Okay? Analytically, if I give you an equation like this, and I say, what are the 4 solutions, x, 1, 2, 3, and 4, in terms of A, B, C, D, and E? Do you know a formula for it? You can do anything when there is a common factor in them, which in this case there is none, there is no x in them, Or if you know a root of this, then you divide this. Let's say the root of this is 1. Then you divide this whole thing by x minus 1, bring it down to the third order, and then try to solve the root of that third order, which again, still you don't know. Okay, so in general, there is no analytic. Now, if you want to find the roots of a polynomial in general like this in MATLAB, the command to use is not a symbolic command, it's a numerical command. It's called roots. And all you need to pass to it are the coefficients of the polynomial. So here you have 1x4, negative 1x cubed, 0x squared, 2x, and 5. Okay? You have to include all of the coefficients. If they don't exist, you put a 0. And this guy will give you all of the roots. How did it do it? Numerically. This is not analytic. And you see clearly all 4 roots are complex numbers. They are not even real numbers in this case. Okay, so one important lesson here is when you do solve, do not expect it to solve anything that you throw at it. It's not going to solve that. It is not. It has some limitations. It can only do so many things, and it cannot do magic and do everything for you. So just keep that in mind. Now, sometimes the equations are even harder. Like, for example, they are not even polynomial anymore. You have something like this. Now what? Okay. Now this is a nonlinear equation. It's not a polynomial. And solving this is not going to be even done by the command roots, because roots is only for polynomial. No, I want to find which x makes this equation valid. It's the root finding. In one of your homework, you did it. If you remember. What was it? It was about anonymous functions. It asks you to create an anonymous function. So set this equal to 0. Call this f of x. Start with some initial guess and let it see if it converges to one of the solutions. What was that function? It was called f0, right? Go look back at your homework. The command f0 will try to converge numerically to 1, not all, 1 of the roots of this function for you. In general, solving nonlinear algebraic equations is not trivial. Okay? They might have a bunch of roots. At best, each time you can converge to one of them, you have to do a bunch of tries to find all roots, if there are roots. And again, there are numerical methods like the Newton-Raphson and others. I don't have time in this course to go over them. It's a little bit above the level of this course, but solving equations like this is not trivial. And Symbolic Toolbox of MATLAB by no means is going to do any help to you. So just keep that in mind. Another command that I mentioned, and I would like to talk about it a little bit, is called eval. Eval is to evaluate. Remember, we used eval somewhere. Anybody remember? We used eval, I guess, last session. Anybody remember that? Come on. Good job. We defined a variable, and it was 2 numbers multiplied, but they define as what? As a string. So when you define it that way, that 2 times 4 is not going to happen. But if you say eval that, now it is going to do it and even convert it to a number. Yeah. No, A is a string, yes. But when this eval acts on it, not only it calculates what's inside it, the result of it is now going to be a double. It's going to be a floating now, it's integer number, floating, whatever it is. It's not going to be string anymore. Now, what's the use of this eval? Well, let me tell you something, which is also good for your project. So one of the things in your project that I mentioned in the past to you is called radius of curvature. Do you remember that? I mentioned it. Come on. You guys are forgetting everything so fast. So I mentioned if you have an arbitrary curve y as f of x, at any point you can draw a circle that is tangent to your path, correct? The center of it is called center of curvature, and the radius of it is called what? Radius of curvature, rho. And I said at any point x or x naught, rho of x is defined as what? 1 plus y prime squared, the whole thing to the 3/2, divided by magnitude of y double prime. This whole thing calculated at x equal x naught. This is the definition of radius of curvature that you guys should have learned in calculus, but I think you didn't. And you're going to need this guy when you go to dynamics. So you better know it. And for projects, I ask you to calculate this. Now, how do you do that? So if I give you a function, okay, any function, sine, cosine, how can you calculate the derivative of it, the double derivative of it, and then evaluate those double derivative, first derivative, and so on at a specific point? Diff command, and then to evaluate the function and the diffs at the point, you use the command eval. No, eval. So look here, let me give you an example, and this is going to be the last part of this lecture. So here, let's say I want some function. So I say y equal, or first, sims of x, and then f equals what? Just anything. Let's say x cubed minus 4 times x squared plus 5 times x minus 6. Okay? So this is my function. Now, I also have a specific point x naught equal to 2. Now, I want to find the radius of curvature of this function at that point. So what do I do? First, I say f prime is equal to diff of f and x, correct? And once. This is that y prime, right? And then f 2 prime, or prime 2, if you want, prime, is what? The second derivative of f with respect to x, correct? Yes? If you want, I can call it y prime, doesn't matter. So y prime, y prime. Good. Now what? Rho is equal to 1 plus what? Eval the y prime, but you have to first calculate it outside, then bring it in. So you say y prime at the location x is equal to, first, before that, you say x equal x naught, then you say now eval for me the y prime. Okay, so you set your variable x to this number, and then say whatever this function is, which is the first derivative of this, evaluate it, okay, with this new x value and call it ypx. And similarly, yppx is eval of y prime, y double prime. And now you say rho equals what? 1 plus this ypx squared the whole thing to 1.5 and divided by what? Absolute value of y double prime at that location. Here, radius. Here we go. So the function was a cubic function. You see the first derivative is square function. Isn't something wrong? Yes. Oh, here, 2. It has to be 2. So the function was cubic. The first derivative is squared. The second derivative is line. Each function is evaluated at x of 2, those two functions. And then radius of curvature at that location is what? 0.7071. Yes? So this eval and diff together can do that radius of curvature for you. Okay, we'll talk about the rest of it next lecture. Thank you. If you remember, last time I showed you how to take the derivative of a function, integral of a function, solve algebraic equations if MATLAB can handle them analytically, plot them, take limits, evaluate them, and I did even the radius of curvature for you, if you remember. So now there are some other things that in Symbolic Toolbox they worth taking a look at. One of the things I love is the simplify command. Remember I showed you a command called pretty, right? Could write stuff in a nicer way. The simplify command is also relatively nice. Let me show you. So let's say you have an expression, and in that expression, you have sine squared plus cosine squared of x. If you just pass it to what? To the simplify command, it simplifies it for you, if it can. So it can do a little bit of algebra for you, right? You see here? And you say simplify it for me, it says what? It's 1. Okay, so if it can, it has some limited capabilities, but that's another one. Exponential of c logarithm of a square root of a plus b. Can it do that? Well, let's find out. Yes, of course, what is a, what is b? So we have to define a, b, and c here. Do it again. And it says yes. That whole big thing is simply what? A plus b to the power c over 2. So what I passed to it was exponential of c times log of, and log here means natural log. So to the c times natural log of then what? Square root a plus b. So it's this guy, right? And you know the c can go to the natural log, be like a power, correct? So this is the same as e to the natural log of square root a plus b, the whole thing to the power c. And then, you know, these two are inverse functions, natural log and e. So the result is going to be simply square root a plus p, b to the power c. And this is like a plus b to the power 1/2. That's the square root, then to the power c. So you'll get what? A plus b to the power c over 2. Right? So it did all the simplifications for you. So the simplify command many times can do a little bit of algebra for you. Okay? It's relatively useful. Another command is called the Taylor series. Okay? Now, I guess I talked about Taylor series with you, right? Yes? What was Taylor series? Use it for what? A function. It's a way to approximate a function using what? Polynomials. Adding a bunch of polynomials and approximating what? Any function, as long as they have some specific conditions on continuity and having derivatives. And it's an infinite series, but if you remember, in order to get a reasonable result out of that, we only need what? Just a few first terms, right? We don't need to go forever. So I write it one more time here, just so you refresh your mind. It says f of x can be written as f at point A plus f prime at point A divided by 1 factorial times x minus a plus f double prime at a divided by 2 factorial times x minus a squared plus dot 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 plus the nth derivative at a divided by n factorial times x minus a to the n and all the way to infinity. Okay? Where a called the expansion point, and if I don't go forever, so I just what? Just use n terms. Let's say I only use capital N terms here, 5, 6, whatever I want. Okay, so I'm not going to go forever. I just stop somewhere and get rid of this part. So now my equivalency is going to be approximation. So this A, again, is called expansion point, and this N is called what? The order of the Taylor series, how many terms you are using. So MATLAB is capable of what? Creating that Taylor series for you analytically using the command Taylor. So let's say if you have the function sine of x, all you need is to pass that function to the Taylor series. Then for order, you pass to it as many terms as you want. And for expansion point, again, what? You pass to it as many points as the point that you want, not as many points, just the point that you want. So here, look. F of x is, or f, not f, f of x. F is equal to sine of x. And now I ask it to, let me expand it about 0.0 because that could be familiar to you. And I use 5 terms only. And this is what you have. X minus x cubed to the 6. Okay, and that is because if you go here, by the way, you have to calculate this as one term. So here, this n is not actually the order, n minus 1 is the order. So when I say 5 terms, it means this is n of 0, n of 1, n of 2, n of 3, and n of 4. So you have to stop at n of 4 here. If I say 6 terms, then I can go to the 5th derivative, okay? So if I want the 5th derivative to be included, I need to use what? 6 terms here. Then I have what? X to the 5 as well. And as I told you, this guy could be a very good approximation for what? For the function sine. We can try it on anything, right? Let's say, for example, let's use any angle that is well known, like what? Like 45 degrees, right? What's sine d of 45? Yes, which is 0.707, okay? Right? That's sine and cosine 45. Now, if I want to approximate it using this guy, what do I do? First, I need to make sure the input here is in radians, right? So x is going to be what? Pi over 4, right? 45 degrees, correct? Now I say eval this t, whatever I call it. Here, I wrongly call it t8, but that's okay. Evaluate this for me, right? Evaluate this for me at this x value that I define, and look at that. Right? This one and what? This one. You see? Those 3 terms are sufficient to give me a very accurate value for what? For the sine function. And I told you that's how your calculator calculates sine, cosine, logarithm, and every other function. Okay, so this Taylor series, which is, by the way, one of your project items, you know how to do it now. Then we have summation of series. I don't know if you have seen series and summation of series terms in your calc course. Have you seen that? You're right now in it? Okay, so let me give you a hard time a little bit. What's the summation of 1 over n squared minus n? N goes from 1 to infinity. How much? Give me a number. Go ahead. Come on, do it. Calc class. Going back to calc class. Do this. Are you sure? Well, you cannot start at 1 because this term is going to be infinity. So I start at 2. You cannot go 1 because you have 1 divided by 0. So now what? Now how much? Yeah, sometimes I need to give you a little bit shock to go back to your calc and look at that. So the way you do this is you write this as 1 times n minus 1. And this 1, you write it as n minus 1. And then you do separation, so you will get 1 over n minus 1 minus 1 over n. So you first divide that by this, and then divide this one by the denominator. So you get this. So this is equal to 1 over n minus 1 minus 1 over n. Now this is way easier. So this is now is going to be plug in 2 here. So there's going to be 1, 1 minus 1, 2. If you plug in 2, if you plug in 3, it is going to be what? 1 over 2 minus 1 over 3, and plus 1 over 3 minus 1 over 4, and you keep going. So if you look, each term would cancel one of the previous ones. So what you will get is simply the first term minus the limit of that 1 over n as n goes to what? Infinity, which is 0. So the answer is simply what? 1. Okay? So this summation, the answer is 1. Right? Now let's do it in MATLAB, see if MATLAB is capable of doing it for us. So I define a series, any series, and then I use the command simsum, summation symbolic. What is the common term of the series? K over k squared, 1 over k squared, 1 over k squared minus k. And then I say k goes from one number to what? Another number, right? Yes, and the simsum command should do it. So what I do here is I say sims of n, and then I say simsum of, what's the general formula for the series? Is what? 1 over n squared minus n, correct? With respect to n, from n of 2 to n of what? Infinity, right? Here we go. Look at the answer. 1. Yes? Symbolic. So it is doing all of that guy for you behind the scene. And there is a similar command called simprod. This one multiplies all of the terms of a series from 1n or 1k to another k. So instead of summation, this is multiplying the terms, right? I don't know if you have seen that in your calc too. Have you? So instead of summation, we use this guy, pi. We say, what is pi of 1 over n squared when n goes, let's say, from 1 to 10? So this means 1 over 1 times 1 over 2 times 1 over 3 all the way to 1 over 10. Okay, you haven't seen the pi symbol? Pi means product of the series terms, not summation. Okay, if you haven't, learn it. This is your MATLAB calc class. So whatever you don't see over there, you see it here at least. Oh, okay. Now some other good commands that I like. What are they? Zoom out. The str to sim. That's one of the nice ones. It converts a string variable for you into a symbolic. And actually, this command is the most important command you need for your project. In your project, what do you need? You need the user to type in the name of a function, correct? But when you want to evaluate that function to, let's say, find the radius of curvature or anything, that variable that you have has to be what? A symbolic variable, not a string, right? So if you say, hey, user, let me show you. CLC clear all, close all. Let's say you ask the user FF equals input, enter the function. F of X. And then you read it as a string, correct? And then you also ask them A, enter the expansion point. So this is your A, correct? And then what? Let's say, and then you have N is equal to what? Input the Taylor series order. Enter the order of the Taylor series, right? So now you want to what? Expand a function that the user enters about a specific point with a specific number of terms. Well, what they enter here, this FF, is going to be what? It is going to be a string, not a symbolic variable. Okay, so first, since they're going to enter it as a function of X, before that, you say what? Sims of X, and then now let's run it. And whenever you get that FF, how do you convert it into a symbolic function? You say F is equal to what? String to symbolic of FF. So now this F is going to be what? A symbolic function. Right? And then you can use what? Your Taylor command, correct? Here. And shoot it out. So now you say the Taylor series is equal to what? Taylor of F with respect to X. Order is going to be N. And the expansion point is going to be A. And then you're going to show it. Yes? So this is something that you need for that project. Read the function, not directly go into your code and type it in. So now look. Here, enter the function, sine of X. Enter the expansion point, 0. Enter the number of series, 6 terms. Boom. Yeah? If I didn't use that str to sim command, it will give me an error when it reaches this line. It says, hey, this F that you are using, it's a string variable, not a symbolic. I cannot do Taylor series on that. But with this command, I do what we call conversion of variable, or the more technical term is called type casting. We cast the variable from one type to another. Okay, so this command is extremely useful. Gradient and Jacobian are good for the people who love multivariables. Okay, if you have a function of more than one variable and you want to find the gradients, or you want to find the Jacobian or anything for a vector, then you can use the command gradient, or you can use the command what? Jacobian. Okay, I'll show you an example. And then I also show you this discontinuity. So let's do it very fast before the next class comes in. So here, look, my function is a function of 3 variables, x, y, and what? Z. It's a complicated function like this. And then I want to what? take the gradient of the function. Everybody knows what gradient is, right? Hopefully. No? What is gradient of a function? Gradient of f of, let's say, x, y, and z means what? Who is in Calc 3 or bin? Go ahead. Partial derivative of f with respect to x plus partial derivative of f with respect to y plus partial derivative of f with respect to z, sum of the partial derivatives. Okay, which is what you can see here. Is that right? Of course not. No, it's the vector of them. It's gradient vector, it's not a scalar. Okay? Whatever I say, you don't say yes. It's no. I want to see you have been to that class or not. It's the vector of these three variables. Each component of it is one of these partial derivatives. Okay? It's not the sum of them. That summation is something else. That's not gradient. Okay? So it's the gradient vector. And you do it here. Now, if it's a vector field, then you can do Jacobian. How many of you know Jacobian? Gosh, it's getting even harder. Let's go back to Calc 1. Finding the discontinuity points of a function. Where is this function discontinuous? I know everybody knows that. So to do it, the command is a little bit different. Okay, let me show you this. So here, you define a function. F here is 1 over x times x minus 1. Okay, so your f of x is 1 over x squared minus x. And you're asking at which x point this function is discontinuous. So the way to go about it is you have to say f eval sim engine discontinuity f and x. What is that sim engine? Anybody has any idea? And it tells you at x of 0 and at x of 1, that function goes to infinity, which you know it does. This sim engine, there used to be, and there still is, some adds on to MATLAB. It was called MuPad. It was like an analytical calculator adds on to MATLAB. Okay, using which you could do a lot of symbolic operations. So when you call here and say sim engine means what? Means do this operation using what? Using that MuPad of MATLAB. Okay, you can just look it up. Okay, so if you want more info, as I told you, it's like a graphical user interface. Okay, it is a GUI, this MATLAB MuPad. And you see, it's like, for example, if you ever use the software Maple, this is like that. So you can type the commands here and it does some algebraic operations for you. This is an extra environment to MATLAB called MuPad, okay? And here, when you say sim engine means use this environment to do that. It has some very good symbolic capabilities, this environment. Okay, so it is using that environment to do this discontinuity calculation.